Here's 10-1, day 3. We're moving to significance tests. Obviously, in day 2, we hit intervals. First orange box there has HO. You'll commonly see we write it like that. HA has the same 3 possibilities that we had before, which was that we could say that the difference of our 2 proportions is greater than 0, less than 0, or that it just simply doesn't equal 0. At the bottom here we have the calculation for our z-score. I showed you an example earlier where the parameter was a different value other than 0. It was in the very first day. I only did that just so you know that it's possible, right? That number doesn't have to be 0. For us in a 4-step problem, it will be. Okay, we'll always be testing against the value of 0. Notice down here in our standard error formula, this is the one and only time pooling comes up, but we use what's called a combined proportion. Simple calculation comes from adding the successes over the sum of the sample size. Okay, what's going on there is in a test, HO says that P1 and P2 are equal. So when we calculate our z-score, we should have our combined proportion that reflects the most likely number that it would be if the 2 were the same. Okay, it depends on the successes, it depends on the sample size. When you run the test in the calculator, it'll give you the combined proportion as well. There's the normal curves that reflect what's going on. If it's a greater than, we're getting a p-value from up top. If it's less than, it's down at the bottom. And if it's not equal to, then we've got components of our p-value coming from both sides. And here is our first context. It's got data from 1994 and 06, studying a possible change in rates of hearing loss. So, here we go. All right, HO is going to say that P1 actually, I'm going to go P2. Now the question did say that we are suspicious that rates of hearing loss have increased from 94 to 06. So HA is going to say that P2 minus P1 is greater than 0. Now if I'm going to make it a greater than, then I need to make it really clear here that P1 is the proportion of teens with hearing loss in 94. P2 is 06. So if I set it up that way, HA is consistent with saying that I think that the rate of hearing loss, or the proportion from 06, is going to be bigger. This will be a 2 proportion z-test. So our random condition, we have 2 simple random samples of 3,000 and 1,800 teenagers. Normal. There's successes and failures from 1994. I had to calculate these myself, and they're coming from 0.15 times 3,000 and 0.85 times 3,000. Successes and failures from 06, and yes, indeed, Those are all way over 10, so our normal condition is met. And we head down to the do step. So here's what our sample showed. That would be you could just have 0.045 there. Okay. So here comes the combined proportion. Okay, you don't have to show your work for it in this step because you can get it off the calculator. Okay. But if you wanted to know, and you should know, it's coming from this. $450 plus $351 over 3,000 plus 1,800. Now when you set it up, you're going to get a proportion between 0.15 and 0.195. Okay, again, this proportion is to reflect our best estimate if these two proportions or rates of hearing loss are the same as to what it is. Comes out to be 0.167. And now my work for my z-score should reflect that combined proportion. I get a z-score of 4.05, which is a huge z-score because we have a tiny p-value. Okay. Same old conclusion though. Our p-value is less than 0.05. We reject HO. We have convincing evidence the proportion of all teens with hearing loss has increased from 94 to 06, right? We always finish with one sentence in context about HA. I accidentally skipped over the context. I can certainly get it to you, though. It's comparing two proportions at a company that are offering cash incentives for their employees to quit smoking. One group, they didn't know when they signed up to take part in this plan to quit, they didn't know that they would get potential cash rewards to quit, but then they were randomly assigned to their respective group, that they got cash to quit or that they didn't. And we're going to compare the rates that they'll quit smoking. Okay? Bottom line, what we have is, and again, I apologize for skipping over that last slide that has the context on it. If you have the PDF document, you can go to the slide before and you can see it. It's called Cash for Quitters. 878 took part. They were randomly split into two groups of 439. For the group that got some cash incentives, 15% quit, and for those who didn't, 5% quit. Fourth step would look like this. We'll say HO is P1 minus P2 equals 0. I'm going to do a greater than. If I set it up there, all right, so I'm saying that in HA that I think P1 is bigger. So P1 has to be the employees that had financial incentives. P2 are are those that did not have incentives. Two proportion z-test at alpha 0.05. Okay? Random, we got to be a little bit careful here. I don't want to refer to random sampling or that they were randomly selected, because they weren't. In fact, the context says straight up they weren't randomly assigned. Okay? Or excuse me, they weren't randomly selected. Okay, so the 878 people that took part volunteered. The context does say that they were randomly assigned. Okay, that can come up with a two proportion or a two sample. You should read through the context carefully and make sure you're hitting the right thing. Were they randomly selected? I'm just going to say that they were randomly assigned to their groups, as in their treatment groups. One had the financial plan and the other financial incentives, and the other did not. Okay, those are all at least 10. Go hit a z-score here. So those numbers, again, I didn't have the context included, but both sample sizes are the same. They're 439. They're both groups. So for the financial incentives group, 15% and 5%. N1 was 439, so was N2. There's my combined. And here you might notice the combined is exactly in the middle. That's because the two sample sizes are exactly the same. That's the way it'll always play out if they're exactly the same. Again, as far as including that part in your do step, you don't have to worry about that. You know, if you, again, just want the reference here. That 0.1 is coming from 22 plus 66 over 439 plus 439. That gets you 0.1. Okay? Here's our p-value. That's how small p-values get if you're talking about a z-score that's close to 5, which obviously there's a really, really significant difference here between these two. Our sample sizes are pretty large, and the rates at which they quit smoking were quite different. There was a 10% difference between the two. We have convincing evidence that financial incentives help employees like these quit smoking. Okay, that we factored in the whole random chance thing. We don't think it's that. It's the difference seems significant that the money incentives made a difference. All right, here's one more. So here's really what we need to take from this data. We have our preschool group. Okay, so these are kind of all kids that you would say from their backgrounds are kind of at risk to maybe not graduate from high school, not get any post-secondary education, and basically be dependent on social services for a good chunk of their lives. Okay? Perhaps they're it starts with falling behind in school. Which could potentially go all the way back, that oftentimes these types of kids don't go to preschool at all. You know, I mean, it's somewhat common that most or many students before kindergarten go to at least 2 years of preschool. So the idea of the study is to track long term for those that were sent to preschool. How did those rates play out for their need for social services later in life? And here's what the paragraph is getting at. For those that were sent to preschool, 61% still needed some type of social service later in life. For those that didn't go to preschool, it was 80. Okay, so it dropped, right? We saw a 19% drop from two samples of, hang on a minute, there we go, a sample of 62 and 61, because there were 123 children that took part, so they were split as evenly as possible. Okay. Notice here, this is one for the random condition that gets into random assignment. So when you get to that point in the test, we got to reflect that it says the 123 children were recruited, right? They weren't randomly selected. They chose to take part in this, or maybe were persuaded to take part in it, and then they were randomly assigned to their groups. All right. So here we go. Now remember, this whole state step, I have to have things set up and the parameters defined to reflect that I think the proportion for the preschool group is going to be lower. Okay? Now that's not going to affect HO, which is, as always, just going to say that P1 minus P2 equals 0. Now here I'm going to say P1 minus P2 is less than 0. And if that's the case, I have to say that P1 is my proportion of the children who did attend preschool that use social services later in life, and P2 did not. Okay? It did not. For random, we'll say there's not a whole lot more I have to say here. Because really on one like this, what I would be checking for is, are you recognizing that the random condition is for assignment, right? Not for that they, we don't have an SRS of 123 because they weren't randomly selected. Here it's a little bit closer, but we're good to go. Random condition is met. Alright, so 0.61 minus 0.8, that would give us a statistic of negative 0.19. Again, I'll use my combined proportion, which is 0.71. Of course, z-score and p-value will come from the calculator. That's what we have. And it actually is the third one today that we will reject. We have convincing evidence that children like these who were sent to preschool were less likely to use social services as adults.